because I only get to see about 4 or 5. But you know, I'm trying to have a you know, somewhat easy to understand conversation about AI. It's a really sophisticated topic. It's not just technology; it's science as well. But I think there's a lot that can be said that an executive can understand that maybe is missed on some others that don't have to deal with the kind of operations and strategy of working in business or having a business even. So can I go ahead and share my screen now?
Please do.
Great. So you can all look at a castle that we're guessing is from maybe Liechtenstein or Germany first. And then I'll share the rest of my screen. Is that good for everyone?
Yes.
Yes.
Okay, great. So one of the things, let me just move these. I didn't realize the cameras were on the notes. So one of the things that I really wanted to talk about to everyone is obviously getting some definitions together about you know, what is AI, what is machine learning, what is deep learning, but ideally give everyone kind of more salient points that you couldn't just find on a Google search so easily, which you could, and there's millions of you know, articles and you know, breakdowns of AI, but I hope to give some points that maybe you couldn't find just on the first page of Google. So
Lucas, before we begin, we already have a question. Will you be sharing these slides?
Yep, sure. Yeah, I can send them after. Maybe I'll send them to Bob or whoever.
You send them to Zoe, and we have a resource center we can post them on.
Awesome. Then yeah, they'll go there.
Thank you.
Yeah, so feel free not to read anything on them if you don't want to. Great. So the overviews, yeah. So in the beginning, we're going to try to get through some definitions and kind of necessary requisites to start to discuss some things. I'll try not to get too bogged down any technicalities. That'll bring us kind of immediately to an activity. It's kind of challenging. You're going to have a limited amount of information to kind of make an estimation as to what type of AI you're witnessing. And I think once we kind of see the answers, it'll be very elucidating of kind of the nature of marketing and AI and kind of the conflation that they undergo all the time with the huge hype that we've had for the past 10 years. That'll bring us into talking about kind of enterprise intelligence and, you know, how humans and machine learning models and software kind of work together in an organization, what they can and can't do, and how they maybe can and can work together moving forward in the future. And then I'll set us up for talking about AI Center of Excellence, which is something I've helped set up at a few places that were mentioned, also places like Moody's, a bunch of industries all around the world, because AI is pretty much domain agnostic or industry agnostic, if you like. And then we'll just wrap up there, ideally with some questions at the end after that. Great. So this first kind of imagery is probably something some of you have seen a decent amount. It's really classic, you know, kind of circle cascade. And what it's really saying is that, you know, deep learning is really a subset of machine learning, which is just a subset of AI in general. What I really want us to focus on with machine learning, you could find a bunch of definitions on the internet, but one thing I really want to look at is what it means when I say any statistical model capable of improving with experience. So improving, as we all kind of guessed, is being able to learn and actually store some of the things you learned. It's kind of similar to us. But the one thing I really want to get across is what experience means with respect to machine learning, and then obviously deep learning even more so. By experience, I mean something very similar to, as humans, what we undergo, which is you receive kind of data. So if you're humans, if I look out the window, I receive, you know, visual data. I might receive audible data. Maybe there's a tiny amount of olfactory data somewhere. But I go throughout my day experiencing this kind of data casually without even realizing it. And the difference between machine learning to start with from, say, some of the kind of old-fashioned algorithms and the kind of non-heavy-duty AI stuff is that it does a similar thing. And machine learning, when it's navigating data, is actually kind of learning through time experiences and getting feedback from them. That's a really important thing I want people to kind of come away with, is that machine learning is in some ways a lot more similar to a human than it is similar to maybe a basic computer or things you think of normally when you think of very technical things, right? Machine learning is kind of soft in that sense. It's not as rigid and hyper technical in some ways as people I think of it, because I think they think of big computers and some of the kind of old fashioned AI that we saw back in the day. Maybe thinking of HAL is a little bit more similar without the moral stance. But so when we go to deep learning, it's just a subset of machine learning. If you say machine learning, that always includes deep learning as well. Deep learning is a small subset that only refers to neural networks. So in machine learning, you have tons of algorithms, decision trees, naive Bayes, regression. It's endless. Pretty much every algorithm math has ever come up with can be put into machine learning context. That's what makes it so powerful. With deep learning, the big difference is it's one algorithm. It's called a neural network. I'm sure many people have seen visuals or already know a decent amount about it. A neural network was made basically in the early 80s through an artificial neural network, it's sometimes called. And it's just a representation of how the brain works and computes. It's an attempt at that, at least. And one of the things that comes away with that is there's not really specified criteria for how it learns. In fact, when you kind of hand a deep learning model some data, it's kind of similar to handing a child something in the sense that they're basically just going to explore pretty much every angle of it, try to gauge at their senses with different computational resources they have right in their head. And it's a very naive yet robust and more general approach to thinking about computation and processing information and solving tasks. And so one question you could have is, well, if you're not machine learning and you're not deep learning, but you're still AI, what do you kind of look like? And that's what sometimes you could call good old fashioned AI or rule-based engines. And that's stuff that I think a lot of people are actually pretty familiar with. It's a much more traditional algorithm kind of stance, kind of an if then, right? If some data, then a consequence. And you can build that up to, infinity, not practically speaking, obviously, but, figuratively. So that's human curated rules. So you could think of, if this package comes in, send a notification to X, right? It's very low resolution. You can get down really granular to literally the lowest level you want of directions. And it's static in the sense that you can't change anything in a kind of rule-based engine or a kind of good old fashioned AI algorithm. That's one of its weaknesses, but it's also one of its strengths. We'll get more into that later. And so what I have here is human intelligence is hard-coded into a closed loop. So what that means is that with a kind of, more logic-based, software-based, kind of some of the less heavy, intense AI stuff that you see, what you're really looking at is human intelligence that was just encoded into a system, rather than a system that learns some type of thing through its own intelligence. So
Lucas, we have a comment.
Yeah.
Are you going to discuss how to verify or validate these models, especially after you make changes to ensure they're still accurate?
I'm not particularly going to discuss that because I thought it was a little too technical, but I could discuss that if there's a specific question around, how that's done. Maybe if they could specify it.
Kevin, go right ahead, Kevin.
Mm-hmm.
I told Kevin to go ahead and ask.
Sure.
Kevin Clare.
I don't think we have to go into detail, but just general approach to it. Because especially as you start getting away from AI and you're getting into things where it's learning for itself, you don't want to get too far down that curve and find out that you're responding to incorrect output. And just at a management level, how would we want to make sure that that's getting done? Maybe at that level, just keep it high.
Mm-hmm. Okay, so one of the things that machine learning does is it has an objective function. You'll see a bunch of different names for that. Some people will call it a loss function, a cost function, an error function, but the most general way to think about it is an objective function. And it's simply a function that's measuring how close the machine learning algorithm is doing towards the objective you want. The objective you want might be something like get 100% accuracy on this image classification task, or maybe there's a manufacturing line going down and you want to look at it, make sure there's no defects and have 0% error, right? So what the main thing you want to do is pay attention to how the objective function is moving upon new data instances, right? So one of the great things about machine learning is it is directly, not indirectly, but directly relating success to the objective function. So as you introduce new data, as you introduce anomalies, as you introduce as many things as you possibly can to it to kind of give the most robust data set, what you'll see is a kind of ebb and flow of its ability to classify error, right? So as a manager, one of the main things you're looking at is, okay, we got a bunch of new data sets or new data fields to look at that we didn't have before, but like, is it increasing our ability to recognize, this, maybe part air in it, or maybe, a face, or whatever the task is you're after. So as a manager, in some ways it's hard because you can't understand down to the most granular level, like if it's deep learning, from the neurons, what's happening. There's a little loss of traceability, just like there is with humans. But from a high level, you actually have a lot that you can go after, because if you have, say a data scientist or a data engineer who's training a model for you, one of the main things you can focus on is, all right, well, how's the objective function doing? Like, are we able to handle, anomalies? What are our number of false positives, true positives? If you're in the life sciences space, that's really big. Something called a confusion matrix. It measures, how many false positives you have, how many true negatives. As you can imagine, you don't want to say somebody doesn't have cancer if they do. That's a lot more important than even the other way around, because it's a fatal mistake. So you can kind of gauge that kind of classification preference right into your model directly. And it's just something you can do with your data engineer or machine learning engineer.
Thank you.
Oh, sure. So this is kind of an important slide. I want everybody who, and if you have experience with, working with data and data science, feel free to think of, whatever allegories or metaphors you like. But for the most part, data looks like a giant CSV. And I think a lot of people have no idea, like, oh, the data's in the cloud and we're accessing it through Amazon or something like that. What's going on? And for the most part, most data is just a giant CSV. If you look in, data lakes or large data storages, it's stored maybe a SQL database or something like that. It looks like a CSV. So if you've never seen it, it's pretty similar. So you have columns, which we would call features. So if it was a person's face, you might say, brown eyes, or sorry, eyes, height, things like that, right? If it was a part on a manufacturing line, you might say, like, density, those kinds of things are features, right? And then you have all these values for the different samples. So imagine this row coming across is the first thing you're seeing. Maybe it's the first image of a cat, and the second one, which it starts from 0, which is a whole programming thing I'm not going to get into, but then maybe the second one is, an orange cat, and it's coming through and it has different features, right? So rows are the new samples and columns are the features. And so what supervised learning does, which is about as technical as I'm going to get in this talk, but it's a really important thing to understand in terms of creating data sets later, is it says, all right, as a human, tell me if this is what you want. So here these three are, it is, and tell me if it is not what you want. So binary situation. Is this desirable or is it not? Is it good or is it bad? So instead of, the rule-based engine or the typical algorithmic approach where you actually put in how to decide whether something is good or bad, you say if X, then Y. We don't do that with machine learning, and especially deep learning even more so. Instead, we say, you figure it out, algorithm, how it's good or bad. That's going to what you're doing. You're going to create a function to determine that. And we'll tell you if we like it or not. And that's the reason machine learning can scale so high, is because we don't try to input how to do something. Rather, we say what we want it to do, and it has to figure it out on its own. One of the downsides is you lose a little bit of transparency, which we're going to talk about in a little bit. So, as I mentioned before a little bit to Kevin, I think it was, we talk about here the objective state. Every task should have an objective state, which regardless of whether it's machine learning or not. And in machine learning, you can program an objective state. Usually they're pretty typical. You want to have no error, or you want to be able to classify more things, or you want to be able to get accuracy on understanding of something. Maybe it's a molecule, maybe it's a face, maybe it's, anything, right? And so if we imagine this was manufacturing line data, and we imagined like all these were different things coming in each row at a time, and we say, yeah, this one's good, no errors. This one's good, no errors. This one's good, no, oh wait, this one has errors. And so the way we do that is we create, say, if you have historical data, which I'm sure we all have seen a bunch of historical data that's doing nothing in some database somewhere. What you can do is you can label that as historical data and see if there's a problem or if there isn't a problem with a subject matter expert in your company, which is usually many. And that'll give you the ability to actually start training an algorithm to do what they're doing at scale. So that's kind of what supervised learning is it's creating labels. Is this correct? Is this not correct? So that the algorithm can make a function to actually figure out how to understand that, opposed to kind of the old-fashioned line. So I'm going to start with, basic image classification, right? We have some kind of amalgamous person here. And if we had a rule-based engine, kind of the old-fashioned way to do it, this would be really hard because you can't take in visual data, you can't take in any type of large, dense data type that like a human would, like actually a picture or something like that, right? You have to somehow find some conditional rules to figure out what a person is. And so you can imagine how many rules it would take to figure out if a person was, Ben Affleck or something like that. For anybody who happens to know who this fella is, it's a fun game that you can Google. It's called the Akinator. Probably the most prolific rule-based engine game on the internet. It's basically 20 questions. And in the typical sense, the Akinator asks you, the genie asks you, do they have brown eyes? Do they have long legs? Do they have this? Were they in a bunch of movies? And then it comes down to a kind of reduction of what the answer might be. Now, if you've worked with that, if you've ever done that before, it's really fun. But if you don't have somebody like, Ben Affleck or, Holly Berry or some really famous person in there, it doesn't do so well. And that's because it has to refer to a static knowledge base that it doesn't update. So we can see already how hard coding an algorithm to do something like image detection is almost an infinitely difficult problem. But if we go to machine learning, we're already making a huge advantage because we can create that CSV. We can start thinking of the features that we think are important, eye color, hair length, etc., as many as you want, and we can start having it go detect if they exist and then classify from there. So in this one, a lot of people think Benicio del Toro looks like Ben Affleck or Brad Pitt or something like that. So all of a sudden, it's doing a little bit better. Maybe it wasn't Ben Affleck in the first one. Maybe in the rule-based system, we said, okay, he has black hair and black eyes, must be Ben Affleck. But that's, when you can go a little bit farther than just a few features, then all of a sudden it opens up to, a huge advantage. So instead of creating the paths for finding something, we're actually allowing the machine learning algorithm to figure it out. And if anybody's familiar, deep learning is basically mastered image detection. At this point, deep learning is superhuman at most image detection tasks. And the way you determine that is you have a bunch of humans look at a benchmark data set, try to classify things, and we see how well they do. If you have a deep learning algorithm do the same, you see how well it does. And at this point, deep learning algorithms are doing far better than most humans on almost all image benchmarks. So that's interesting. It may not be a giant general intelligence, kind of like a calculator is better at doing arithmetic, but it's a much more sophisticated task. So that's where we are now. The interesting thing about deep learning is opposed to obviously rule-based engines, and even more so than machine learning, or even less so machine learning, instead of creating features like hair color, height, all these things, we just simply have the algorithm look at pictures of people and learn, just like we do. And that's one of the main things I think people, as they start to understand and get more comfortable with deep learning specifically, will realize is in some ways it's more comfortable than logic-based algorithms and rule-based systems because it's much more human. It's prone to error, but it's also can generalize a lot more. And if you were to look in our brains right now, you'd see a latent space, which is what this is called, that actually looks kind of like this. Now, to be fair, humans don't do as well as deep learning algorithms because we're not walking around all day trying to focus on classifying Benicio del Toro. But that being said, we still have a general capability to do that anyway. And that's one of the main things I want to kind of get across with deep learning. So I'm going to talk a little bit about some words that people use in AI that I think should be broadcasted everywhere. For some reason, explainability is not a word. I wish it was because it's one word that everybody uses in conferences and literature. So to start here, we have, a rule-based engine, as we talked about, if this, then that, right? Something we can all kind of understand from a, kind of rudimentary cutting situation. And we have really high explainability. In fact, we can explain it way better than we could any human decision. We can literally reduce it down to the causation, the ontology, the if what, then what, right? It's very accessible. A lot of people can do it. If you can write Java or Python or anything like that, you have any coding experience, you can already make conditional algorithms, right? The general intelligence is really low. Arguably, it doesn't even exist. It's similar to a calculator. A calculator can embarrass you in terms of math, but once you show it an image, it literally is doing nothing, right? So it can't generalize too well, but it's very specific. So sometimes when you want something to do something very specific and never fail, that's when you need a rule-based engine. And of course, everybody in the tech world knows that like the back of their hand. Now with machine learning, it's a little bit of a different situation. So now instead of automating human actions like we had with rule-based, we're automating human decisions. So the actions are being carried out by the machine learning algorithm, not being hard-coded in. But the decision as what those actions mean is now being handled by another source of intelligence that isn't human. And so your explainability drops down a decent amount. If you have something like a decision tree, if anybody's familiar with it, a decision tree kind of plays out similar to rule-based engines. They kind of work on an if-then system with something called entropy, which makes it a little bit more fuzzy. And there's a chance for explainability on those things until the tree gets really big, and then you're running into some trouble. They're relatively accessible. There's tons of machine learning algorithms. There's a million courses out there that undergrads right now could do and solve a lot of problems at companies. The general intelligence is a big kick up. You can have machine learning algorithms that classify images, that classify voice, that classify any tabular data you have in any industry. Maybe they can't generalize as much as deep learning, but they're probably going to be where most of the a lot of the value add is for most industries that aren't trying to solve some random academic benchmark. So that means when we get to deep learning, as I'm sure everyone kind of expected, our explainability is down really low. And that's been a big problem in industry. It's questions that obviously I get a lot, and everybody gets a lot. And part of that is because I think we're used to rule-based systems where we treat them differently than we treat people. Like, we don't try to ask people to reduce down to the lowest atom why they made a decision, obviously. We actually go much more shallow than that. And I think if we start treating deep learning similar to humans, we'll find that we get a little bit more potential explainability than we can even get with humans, maybe with a little bit less accessibility, because with another human you can just ask them why they did something, as Bob was talking earlier, the beauty of language. But then you get this amazing bonus, which is general intelligence. And of course the limit of general intelligence is something called AGI, which is the singularity, the explosion that a lot of people in the kind of sci-fi ethos are kind of waiting for. I don't think that's going to happen anytime soon, and there's a big argument as to whether it's possible at all. But regardless of the sci-fi kind of scary parts, deep learning is great because we can apply it to so many tasks. It takes image data, it can take audio data, it can take pretty much any data a human can. And so it's really robust towards anything that is not so straightforward to make kind of rules around or make decision boundaries, even in machine learning sense. So you're literally automating human intelligence in general with deep learning. Now we're going to get into later why that is not a full automation, and it perhaps never will be. But for now, let's just say it's that. So I want to look at some examples. I'm sure everybody's familiar, or a decent amount of people are familiar with, smart assistants, Amazon, Alexa, Siri. I know Google has Google Home or Duplex and some other things like that. Here we have a manufacturing robot. I think there's some people here in manufacturing. I don't know if you happen to be in automotive industry, but I think something we've all seen before, kind of robot arms, they're everywhere. They really blew up in the past kind of 30 years, especially internationally. So I think everybody's kind of familiar with that. So if we look at this first one, the smart assistant, the input is audio, natural language. You could have it in your kitchen. You could say, hey, Alexa, play David Bowie, Ashes to Ashes. And it'll go, okay, and then it'll play it and it'll understand it. And nobody coded that rule in necessarily for it, right? It just simply could understand human language and make its own operations off of it. And it outputs audio. Now, what does the training look like? Billions and billions and billions of labeled speech clips. So now most of them are not labeled by humans. There's a way to kind of label things artificially when you need to go at this scale. But it's actively learning through people talking to it, and it's listening sometimes more than it should be. And that's how it gets so powerful. One of the outputs, or one of the consequences, is that you have highly variant behavior. You could get, like I said, David Bowie, you could get Bob Dylan, you could get a rap song, you could get a movie, you could get anything out of it almost. Anything that can play from an audio sense can come out of it, as long as it has access to the web, which is its knowledge base, which is a massive knowledge base, as I'm sure we're all aware. So that's kind of smart assistance. And if you go to the manufacturing robot situation, your input is a protocol program, right? It might be very, very, very sophisticated and refined and heuristic, but it's some type of protocol program that you want to basically reproduce and have come out at the end into a kind of kinematic, which for anybody isn't aware, kinematic just basically means moving loop. So the idea is it kind of has a repeatable process that will do every single time, and you won't have to worry too much about error as long as you maintain it. And so the kind of output behavior is precisely bounded, as we talked about earlier. And that has its massive advantages and it has some massive disadvantages. For the most part in manufacturing, and I'm sure if there's anybody here, they can speak to it. In manufacturing, there are instances of deep learning and machine learning. Like one I mentioned is maybe you have, kind of a line going down across, you have some products on it, and you're trying to use image detection, so image classification on the deep learning side, most likely, to see if there's some type of visual error, which normally we have humans do. It's not the greatest job for humans. It's kind of very, very below, very below the level of, intelligence that humans are usually willing to contribute. So it's kind of a job that we'd like to see shift somewhere else. We'd like to see humans doing something kind of in a similar way as the Industrial Revolution, where we didn't necessarily lose jobs, we actually grew jobs. We'd like to grow jobs that are a little bit more indicative of the general intelligence that humans have. And so that's the kind of thing you might see machine learning and deep learning kind of come through more commonly. They're just kind of burgeoning, they're just kind of starting in this industry, but there's areas where you'll probably never see deep learning and machine learning because you want 100% the same thing every time without any type of error potential for it, right? So there's always going to be a kind of mix probably of robotic kind of sequences through just repeatable processes. Cool. So this is where I want to go into an activity. I like to kind of start it early. It's just classifying some quick AI types. I'd like to take some questions if anybody wants any before when I put the screen up. I think it'll take around 10 minutes, but feel free to take a little bit more if you need it. Technically, you could probably make this classification in your head in 10 seconds, but I think you'll need some time to discuss. It's not a straightforward question. You have limited information, and my hope is that this kind of prepares you to talk to AI vendors or data scientists or anybody you might be talking to, whether it's a sales situation or all the way down to an engineering situation. You need to understand, like, is this propaganda? Is this legitimate? What am I looking at? It seems like it's X, but is it really Y? So I'm trying to give kind of a difficult situation that we can hopefully learn from. I'm sure some people will kind of get it. But it's a pretty basic question. So I'll put the screen up, and I think we'll have somebody kind of navigate how we get to some of the questions. Should I explain before how to do it, or would you like me to kind of set up the breakout sessions and then we'll explain, or how should we go about it? I think it's Zoe?
Yeah, I've got the rooms. So do you want people to be able to see this when they're in the rooms?
Ideally, but if they can't, I could explain it now.
Maybe if you explain it, and while you're explaining it, everyone, if you want to just take a picture on your phone or a screenshot, might be easier so you can refer back to it while you're in the room.
Sure. Yeah. So if you remember it, you won't need it. It's not too much. So let me start. So there's two AI systems here, right? The first one is something called Sophia. She's a robotics kind of element or entity. And then the second one is just a fraud detection system from some bank. We don't necessarily know. We don't know too much about it, right? And as the input, we have somebody just saying, how do you feel about humans to Sophia? And Sophia outputs this kind of soliloquy, or kind of very nice looking kind of paragraph. And then for the fraud detection system, we have inputs, some sort of live data, we don't know what it is, and some sort of historical data, we don't know what that is either. And with the point of this algorithm is that it detects anomalies, and the output is just simply an alert. So maybe somebody at the bank then responds to it, or messages somebody else or whatever, but the output is an alert compared to a kind of paragraph in natural language. So the question is this machine learning, or is this a rule-based engine, machine learning or rule-based engine? I promise it's not a trick question where they're both or they're neither or anything like that, but it isn't straightforward. Cool.
Great. So if everyone's ready and you got your explanation and you have your screenshot, I'm going to go ahead and open the rooms. You have about 10 minutes to discuss amongst yourselves.
Well, it's 5:40. You want us back at 5:50, Zoe?
There's going to be a timer there for
Okay.
everyone. Yes.
Okay, great. So the thing I like about that question is, as I was telling my group, sorry for hearing redundant information if you do, I like this question because, I used to ask questions where you had all the information to answer it, and I was just in a room with executives and they all figured it out. So there was never anything learned, really. So I tried to ask a question that is somewhat open-ended, not really, you don't really have much information to kind of go after, a real way to tackle, like kind of refine down. Well, it can't be X, it has to be this. And I kind of saw that in the group I kind of got randomly sliced into. And so when we see the kind of answer, you'll kind of see how the kind of trick that is played, and I'll talk kind of about the difference between propaganda and some of the current kind of hot topics in AI right now around that. So here's the answer. Now, if you said machine learning for Sophia, a couple things could have happened. You could have actually had a decent amount of prerequisites, knowing a lot of NLP, knowing a lot of things, and that might have gotten in the way actually, because one might look at Sophia and say, well, damn, I mean, that's like a really sophisticated response. I mean, almost only a human could say that. And the sad consequence is a human did say that. So one of the things about Sophia that I personally am not a fan, I'll come out with it. If you're into it, I understand there's an argument to be made. But the Hanson Robotics that makes Sophia argues that the personal kind of human touch that Sophia adds gives people, a good understanding of how AI is going to be in the future. For me personally, I'm not a fan, and the reason is because what Sophia is they hard code responses to hard coded questions most of the time, and that means that it's really no different than a system an expert system from 1978.
May I ask a question?
Yeah, go for it.
Would Sophia have an answer if you used ask the same question in different words?
So the way they end up doing it very often is they have set up questions with set up responses. So the indication then is no, or the same response would come no matter what question was going to come anyway, which is usually the answer. Now they've
like
kind of been
your kid's robotic toy that speaks to you, right?
Yeah,
Okay.
exactly. And now I understand there's definitely an argument to personifying AI and kind of humanizing it and that kind of thing. But I kind of agree with Jan LeCun, who's kind of one of the leaders in the AI space, that I think it's more so confusing to people. And even if you know a decent amount about AI, you end up having a false assumption when you're looking at the system, which in this situation looks like a person. So you kind of think of like all these kind of futuristic things, but in reality, under all that sophisticated stuff that happens under the robotics of it, it's really just a basic algorithm that we've all seen before. And I think almost everybody I saw got the fraud detection one right. Even with the limited amount of information you have, there's almost no fraud detection systems that just rely on a rule-based engine. They have tons of rules in them, don't get me wrong, as they should. But the main engine that is actually classifying anomalies, which is in this situation anomalous pattern detection, is machine learning algorithms, sometimes naive Bayes mixed with some other things, just typical anomaly detection algorithms. I appreciate everybody for humoring the kind of hard question, but hopefully kind of not necessarily open your eyes, but kind of let you know that like even if you know a decent amount, like people are kind of out here conflating some of these things with some of their, I would say kind of profiteering efforts. But either way, watch out for things that look like they're really fancy and they're just some person on the back end who is really fancy because they have a whole brain that is, actually putting in the responses. Cool. So I kind of want to go into a new section. I know some people are going to have to bow out soon, but we're going to talk a little bit more about, let me move those cameras again. We're going to talk a little bit more about just intelligence in general and what it means when you're talking about systems. So again, if we go off of what we just kind of saw or learned, if some of us are learning some of it, in a rule-based engine, a human decides what matters. So they decide what features to consider, if X, and they also decide how to use it. They hard code a path, they hard code a rule for how to use those things. In machine learning, you have this kind of hybrid setup, right, where a human decides what matters, what features you're going to actually put in, but the model decides how to use that, kind of as we talked about before. So it's kind of a synchronistic or a synchronized kind of effort. And in deep learning, especially as somebody mentioned earlier, in unsupervised situations, which is even more so, but even in supervised situations, a model decides what matters. So it decides what features it's going to pay attention to, because as we talked about, the objective function doesn't care if some feature is really cool. If it's not helping the accuracy, it's just going to throw it out. And then on top of that, it decides how to use it. So it's a completely closed loop from an intelligence perspective. Not entirely in the same way that a computer isn't a completely closed loop either from an intelligence perspective. Somebody had to build it. But from the kind of artificial closed point of view, it is end to end. And so that kind of leads us to something called that I call the intelligence inequality, which is the more decisions an algorithm can make, the less we tend to know about how it makes them. So you could look at the upper extreme of being human beings. We don't know why we do anything. We think we do, and we have a good idea about why we do a lot of things. But in general, I can't reduce down anywhere, let alone to an atom, or even a few thoughts down. I don't, I have a couple basic causations in my head as to why I might perform something or do something, and then I'm done. I tap out. Humans, basically don't have the ability to interrogate their conscious, let alone their unconscious. But unless there's Jung is around or something like that. But one of the advantages we get is we can generalize pretty much, ad infinitum. We can multiply two numbers together, and we can, write, a soliloquy. We can do all those things. So that's the cost you have to, seemingly, at least as we understand it. It's a theory. That's the cost we seem to have as general intelligence increases. And of course, we see at the far other end rule-based engines, as we kind of talked about before. One of the things I want to talk about that I have personally just seen a lot happening is the kind of devaluation of human intelligence with respect to solutions. I kind of have seen that, out of the kind of contrived situations of, oh, let's automate out our workers, that I think, maybe I would hope is demo day at this point. People still don't really take into account the kind of expertise that, many employees have, and how that can impact, total solution systems that might have AI in them. Plus, more than 4 million years of training, just the hominid brain. So the hominid brain, for anybody who isn't aware, is basically the brain we've had since the great apes. And before then, that there's a lot more million years that got up to that point. I can tell you we don't have a hominid brain yet in artificial intelligence. So you have 4 million years of just raw training, and then you have 4 million years of culture on top of that. So for people who think that, like, oh, we're just, we're 5 years, over 10 years, over 25 years out from, AGI, this kind of singularity explosion. If you ask a lot of genuine researchers, maybe not Ray Kurzweil, but actual people who are in AI and not necessarily just technologists, I think you'll find a much more pessimistic response. I know I have most of the time I've asked thousands of people, really. And the main point for that is that there's no theoretical reason to believe that we can reproduce the human brain without 4 million years. So to a certain extent, I think, sorry about that, to a certain extent, we have to start to really consider, like, all right, well, how are we going to actually integrate humans into artificial intelligence over time? Because we're not going to be automating everybody out of a job. So we're, if anything, it's going to be like it always has been, and we're just going to be shifting to different style of jobs. That's usually how the kind of technology curve has pushed us. So while we still have, these kind of basic motivations, our collective intelligence has brought us to, a point that no one single mind could have got on its own. And I think that's something we need to really start thinking about, how to kind of get that into our data sets and into our processes. So that just brings us to a kind of simple intelligence loop, which is, matching intelligence to tasks. I can't do 22 times 35 in my head. Some people can, and it's kind of impressive. I would have to probably do the actual calculations, carry over things. But a calculator can do it in way less than a second. A calculator is better at arithmetic, 99.9% repeating than a human is, even savants at speed, at least. So, that's a really important thing to remember when you just have a calculator just sitting in some desk somewhere dusty, which is that, while humans are really amazing with general concepts, they can still be defeated by a mere calculator from 30 years ago or more. Well, the original calculator, even a giant computer. And so I think when you start to think about narrow intelligence and general intelligence and the disadvantages and advantages, we start to kind of come about a different, enterprise for how we're going to perform work. And so that kind of brings me into, talking about what does it mean to set up a center of excellence. I've set up a decent amount of center of excellences with respect to data science or AI or whatever synonym you like, in multiple companies in many different industries. And, like, I kind of get the same things every time when they're focusing on, like, what are the big moral things they want to avoid, what's undesirable, what's desirable. And the first one is always bias. I pretty much always get questions about bias. It's really topical right now. My computer seems to have reset. I don't know if everybody can see me, but here I am. Okay, we're there. 1 second. There we go. Okay. Something happened in Zoom, but we'll try to work our way through it. I'll look at the other screen. So obviously in bias, everybody's focused on how models are creating bias or how data engineers or data scientists are instantiating bias into data sets. And that's really important because it's most certainly happening, and it will, in my argument, always happen. And you want it to always happen, actually. But what I think it's kind of an ill-posed point of view, an ill-posed kind of question. What I think a lot of people aren't understanding is that bias is basically how you make decisions, how you cut decision boundaries up in your brain or in a machine learning algorithm. And so what we should be looking for is what are the desirable biases, not how can we eliminate bias. If you eliminate bias, you won't have any classification, I can assure, but rather how we can think about the set of desirable biases we hope to maintain and how we can allow them to change, because our biases 20 years ago were very different than they are now. And certainly 200 years ago they were. So in terms of the phenomena to the data set, well, if you run a business that's based on anything, you can't really change that part. That's how the kind of business is based. So what you're really concerned with is the data set to the model. Now, the argument there is that machine learning algorithms will bias towards whatever works best. And to a certain degree, that's true. And if that comes out with certain things, like one that's really hard to avoid is racial bias sometimes, right? Because to a certain extent, different racial biases allow for different classifications that we don't really want. And that's a really hard thing to avoid in machine learning algorithms that are really greedy. They're really greedy on accuracy. And so a really big part of setting up kind of a data science program, depending on what you're doing, of course, is kind of thinking about like, what are the set of biases that like I want, like, do I want things to be more diverse? Do I want things to be less diverse here? Do I want this to be not considering this type of thing? Those are really the things that you have to decide at just an executive level or a high business level. They don't need to be decided in a technical sense. And then you need to kind of follow them on down. It's hard to go the other way around. If you go the other way around, you'll just get whatever works for the performance you happen to be thinking about at that moment. And one of the things that kind of lends you to avoiding things like bias in manners you don't want is something that Andrew NG's kind of recently been a proponent of in the past couple months, and I've been saying something to the effect for the past few years in a similar way, which is going from model-centric AI to data-centric AI. And the main reason that I want managers, directors, executives to really start thinking about data-centric AI development or data-centric data science development, whatever synonyms, is that you have control over your data sets. You don't really have control over models. Most people are hiring a vendor or a data scientist to come in and make some models, but the data scientist is reusing some type of model and then applying heuristics to it. But with the data set, you own it. I mean, a data set is to a certain degree a representation of some phenomena of your business. So it's really important to think about, like, how can you improve the data set performance, not just how can you improve the model performance. I mean, it's very obvious in the objective function how to improve model performance. You want to get error to 0 or accuracy to 100 very often, but in data sets, people are starting to not really focus on that. And I think data scientists and AI kind of engineers and the community are partly responsible for that. And I think we'll talk about it in a couple seconds. But so if we look at a contact center data set here, I've worked in companies that have a lot of contact centers. I worked with a company called Benefits Data Trust, if anybody knows them in Philadelphia. Their whole company is a contact center. They basically reach out to people who can have certain benefits and don't realize it, and they help them get access to it. So their whole business model is based around this kind of relationship center. It's really more than a contact center. So all of a sudden, they're really thinking about the features that they're kind of tracking and they want to improve on. So for them, there's things like sentiment, which is an engineered feature, right? They're using a machine learning model to say 0 or 1 or -1, which is it bad sentiment? Is it called good sentiment, or is it relatively neutral? When that's the thing you have to focus on, all of a sudden you have to think about what are the saliencies of certain fields. They had certain fields they thought were going to be like killer, like this field is going to be predictive of so many things, how many people are going to call, what the experience is going to be like. And it turned out when you threw it in the machine learning algorithms, they were all pretty much redundant. They could all be basically traced back to one feature, which was call time, which was kind of interesting. I think the only way to really test that is to think of machine learning as a model to improve your data sets rather than the other way around, which is data sets as something to improve your models. And that's a hard kind of shift to make. But I think if you make that shift in your business, you all of a sudden get to own a lot of the process, because you own your data sets and you own their progress, and they're longer term than some machine learning model that's going to be outdated in a year and a half. And I think that's a really important just cultural shift we need to think about. So, if you have a data centric approach, you're using machine learning models to determine data saliency, as I said. You're ranking those features in order of their performance, and you can do that directly with the machine learning algorithms. And you're collecting more data in order of performance. So you're not going to collect a bunch of data that might be expensive or time consuming to collect if it's offering less than 1% to your accuracy. But if there's something that, when there's more of it, has a huge change, maybe 5 to 6%, all of a sudden you might want to collect more of that. And then ideally, you can use something called unsupervised learning, some other stuff that I heard some people talk about in the breakout session, to speculate on new features that you're missing. You can make a graph, you can make a visual representation. You kind of see like, what are things that we could be collecting? What could they look like that we aren't collecting? Maybe they'd be really cheap or easy to collect, and they'd offer a lot. And so I think, beginning to treat your data sets like high value assets is probably one of the most important things, I think, in the next 10 years for people who are trying to be data driven. Whether you have a big data science program or a big AI program, or you don't have any, we have an analytics program and you can't tell like when is this data science, when do we start integrating it? I think regardless of the synonyms and the misnomers and different words everybody uses for everything, I think your data set is pretty straightforward. And I think a data set is basically timeless. I mean, when does a data set become useless? When you have a better data set or you're not doing that thing anymore. So it's a really significant asset. And I think you should treat it like a financial asset, and you should have a portfolio of data sets, and you should think about, what one does that the other doesn't, and where there's redundancy, and how you can have kind of independent data sets that are doing very different things that are really valuable, right? I worked at this organization where the main thing they did is they did telepsychology, so kind of in the telehealth space, right? People call in for psychologists, and they call in for much more mundane things, even like life coaches and certain things like that. Those actually are more the call. And what we found is, and it surprised me, but I had to look, is one of the most valuable features they have is the moon phase. Now, I don't particularly utilize, horological data or talk about the moon phase in my personal life, so it has no meaning to me. So my bias would be to not care about it. But a lot of the users there happen to call predictably based on different moon phases and based on different horological significant events and time periods. That actually ended up being one of the most important features that they use. It wasn't the most predictive feature. Of course, time of day is a little more predictive. People weren't calling at 2 a.m, but moon phase ended up helping a lot of edge cases that never would have been matched by any of the other features. It was a very non-redundant feature to include. It gave you a certain amount of predictability of a very few amount of edge cases that will continue to happen. So I thought that was kind of interesting, and I definitely wouldn't have thought of it. I'm sure a lot of people have kind of had a similar feeling. Everybody was rushing to make a data lake, a few years ago. And some people are still kind of in the process and throes of it. And I think we kind of all saw that, we rushed and did this, but the ROI is not even matching, the investment that we put in, let alone meeting it with, growth. And I think a lot of that is based on an initial misnomer that the AI community provided to the world wrongly. And that one is why the big data craze. Big data is probably the biggest term outside of maybe AI and the kind of all hype buzz and marketing. And I think it's partly our fault, because in 2012, if you look on the left, basically a machine learning engineer in a graduate program named Alex Karpathy. He humbly named a machine learning model he made AlexNet, and it achieved superhuman performance on an image recognition task called ImageNet, and image database. And what that did is it allowed the industry to understand that, wow, we can actually start taking some of this technical stuff from theoretical academic research groups and applying it to our actual business processes in production. And then 2 years later, all the big three, Google, Apple, Amazon, they all had big NLP smart devices, coming out with things like Alexa and stuff like that, already interacting. It only took a few years. And then everybody else kind of followed suit. And what that did is it made everybody go we got to collect a bunch of data, because deep learning doesn't have features programmed in, it doesn't have all this stuff. So we need to really make sure we have the right amount of data. It's got to be huge. And it is true with deep learning, like more data is always better. But for the most part, and I can speak from experience, I've worked on many ML projects for my company, for other companies, for different things. It's never been true that quality data was not as important as a lot of data. Quality data has always been more important. Most tasks don't need deep learning, they need machine learning. And so if we kind of look at in the rundown, I said, the AI community correctly told the world that sudden technical boom was because of an increase in data volume and raw compute power. And it's true, it's 100% true. These algorithms, deep learning algorithms, deep learning really came out in 1980. Artificial neural networks were already, existed in academia, and people had been thinking about it for many years. Arguably, Turing was thinking about it already, many years ago. And raw computers just got way faster. And so it's true. So everybody's like, oh, we got to get big databases, we got to get big servers, we got to really create this massive data lake, and we're just going to be killing it. And everybody kind of forgot about the data integrity and quality. And that's a really big problem, because it really knocked down the general literacy that everybody has, including for data scientists. Data scientists just started looking for volume instead of saliency, really, to be honest. And that's why I think a lot of data lakes are just sitting there as kind of vacant lakes with not many boats sailing on them producing anything. And I think, that's something we can start to correct as we start to realize that, we're not all going for this benchmark that, Alex was when he made AlexNet. That was this very specific thing in a very academic setting, right? We all have much more realistic problems than such kind of benchmark situations. And so I kind of, this is a very low resolution or a reduced kind of a reductive kind of version of some of the stuff that I've kind of worked on people with. But to really kind of reverse this process that we've been in of kind of creating these data lakes that don't really return a lot of value, we can start by creating a map of all known data sets. So everybody probably has data sets already somewhere. A lot of companies already are storing their data sets on-prem, on cloud, everywhere. They have data engineers. There's a whole level from no data to tons of data sets that are all well tracked and everything like that. So if you already have all known data sets mapped in one centralized area, understand what they are and what they do, then you can start ranking them in terms of their ROI. That's a really important thing. If you can't start thinking about your data sets in terms of how much they're helping you, you're basically just collecting them for hype. And that can work in the long run if you get a bunch of good maybe consultants or something to figure out what to do with them. But for the most part, you don't want to have other people decide what is valuable for you, especially when it comes to AI, because as you've seen, there's a lot of propaganda and there's a lot of people who are just trying to get in the door. And then they put in systems that are not really significant AI systems because they can't, because they don't have good data. So you start ranking these data sets in terms of ROI. That's something I could go into for a long period of time as to how you do that. It's not necessarily straightforward, but it shouldn't be as complicated as people try to make it sometimes. You incubate data sets in a new shared cloud instance. So if you already have a data lake, if you already have data stored in a bunch of places, start incubating it in a place you can look at all at once. It doesn't have to be the whole data set. Maybe you have a data set that's got 500,000. Take 5,000 out of it, put it in some cloud storage, and call it this data set, right? And then take another data set and put it in the same place, and start actually looking at a portfolio of these data sets that you can work on from a kind of incubated machine learning perspective that you could hire an intern to start to work on, and match up the AI model objectives with business objectives. So as we said, there's literally an objective function in machine learning models, right? So the point of that is to reach the objective that you set out. If you can word your objective in terms of error, in terms of accuracy, in terms of net gain, all these kinds of things, that really helps, because that's exactly how machine learning algorithms tend to think about it. If you can't, there's probably things you can do in between that somebody who knows what they're doing can really help with. And then start to track quarterly change of data set performance. And for executives, I mean, to me, this is the revolution of profit and loss that happened a long time ago, which is like, if you don't start thinking of the work you're doing as an asset, then you can't really measure if it's changing in a positive way or not. So if you have this portfolio set up of all these data sets that are going to do certain things, and you're running machine learning algorithms on them, you can start to actually track like how much those data sets are providing value. If you can't do that, I would argue that you never really have a stable predictive curve for your future of your entire enterprise with respect to AI. And so I think that's really important. Even if you're not in the financial space, you don't think of like a portfolio and independent diversity that exists within it and all that stuff. I think it's really important to start thinking of data set as a significant asset that can sit next to another significant asset, that next to another, and they can all be doing ideally not redundant things compared to each other. And then you just keep growing from there. I've seen a few companies do kind of instantiate this process, and I mean, yeah, it helped that they didn't have a giant data lake before to try to get over to that process, but I mean, they were just killing it because of this the simplicity of it. If all you have to do is manage this portfolio, then you don't need a lot of people in the higher ups to know that much about data science, which right now it's really hard. Right now, if you don't know anything about data science, you might be getting killed by things that just aren't happening, because there's a huge disconnect between the machine learning engineer making something and the executive that's trying to push a campaign. So just a little quick note before we leave. I think this is just happens to be an important thing that I think a lot of people need to hear is, yeah, you can go hire a bunch of data scientists for high six figures, and they can probably figure out a lot of stuff on their own, and they're very good, and there's some people who are really talented. But to a certain extent, as I said, in 2012 is when data science kicked off, right? Before that, it was just in the doldrums of academia. I was there and nobody really cared about it. So it's not even 10 years old. So that means that the kind of subject experts and some of the best people, I'm running low here, and some of the best people are actually, still young. Some of them are students. I mean, some of the best people I hired are undergrads, which would be pretty much unheard of in even computer science, let alone any STEM field that's been around and significant for the past 50, 60 years. So I really think it's important that people understand that, a lot of the expertise and the value that can come from hiring people exists in lower age ranges, just because of the novelty of the industry. It really is less than 10 years old. It's not even 2022. So we really are in the kind of very beginning of it. There's not anybody who says they have 30 years of experience or 20 years of experience in AI within the industry is just, I don't know, maybe they're one in a million, but I don't know really anybody like that outside of the godfathers like Andrew Ng and Hinton and these kinds of people. Everybody else is 10 or less. So if they say otherwise, they're probably just a technologist who did something that was kind of related to the field, because you have to remember it's such a scientifically driven thing. It's not just technology. So you really have to have those kind of graduate degrees and stuff to really actually understand it. And now with the undergraduate degrees in data science, you can hire an intern that's a data engineer to kind of start this process of creating these data sets that are just high value data sets, not redundant, not a waste of time, just for fun. And just have an internal SME kind of supervise it. Give them kind of a vision of like, this is what we're going for. We're not trying to make something fun. We're trying to make something that really actually provides value. And I think that's a pretty inexpensive way to start compared to how I see a lot of people starting. And if you have a center of excellence set up, you've cut like almost all the costs that you would otherwise have by going back and forth, and then ending up with a data lake that has kind of mediocre models on it. Cool. So that's pretty much it for me.
Lucas, we do have a question from Susan.
Awesome.
If she wants to
Yeah.
go on mute.
Sure. Let me just get my charger.
Oh, you want me to pitch it?
Sure. We like
Okay.
engagement here.
It's a little out of scope, I think, or off topic.
He's going to
But-
be right back. Just
No,
give
I'm
me a
here.
second.
I'm sorry?
He'll be right with you.
Oh, there he is. Okay.
Yeah, I'm good. Yeah.
Go ahead, Susie.
Okay.
Yeah, you're good. I'm here.
So if you have a large pool of data, I wouldn't even say it's sophisticated enough to be a lake, but let's say you have a large amount of data and you suspect it has a lot of different if then kind of things, but you suspect there's some trash in the data. And is there a way to salvage data that has been culled from a large number of people with a certain amount of I'm not going to say error necessarily, but not
Inaccurate.
garbage.
Mhm.
Garbage. Sometimes people put garbage in, you get a garbage out.
Mhm.
So
Yeah.
that's what I'm wondering. Is there any way to? I know that's a little elementary, but
Well, I mean, it's elementary, but I mean, my whole presentation is an argument that the foundations and elementary things are the parts that we're missing, right? We have all the fancy algorithms and stuff. So, I mean, on one hand, you could say, well, you should really focus on then creating more integrable data. You could say that, but it'd be nice to have something else at least in parallel, right? Or to replace that, you know, it was like, well, we already have bad data, so what are we going to do? I think a lot of what you can do is you can, for one thing, like I said, you can create a kind of data saliency map for the data set, right? So assume you have a data set, like you said. What are the features that from a machine learning perspective are doing well? And maybe it's because they happen to not have as much error in them. Maybe they're not the best features that are telling the most information, but they just happen to have no error, right? So you can, if you can kind of rank those, you know, in one day, you could have a machine learning engineer do that. And you can kind of rank them in terms of how valuable they are towards error or towards accuracy or whatever the objective you kind of set. And then you could see like, well, how much of it is because there's no labels, or how much of it is because there's, you know, what's known as error in the labels, which is could be like, you know, there's a field that should say something like yes, and it says like quotient, you know, 2 or something. It's like, what is that, right? And then so a data engineer in that situation has to kind of go through all those, you know, it's kind of like a Control F situation or Command F if you're Apple. It has to go through all those and see like, well, how much error is there? Take a percentage of error of the data, and then see if they can rewrite that with scripting. So that's where anybody here who's, you know, familiar with a lot more of the kind of software practices could tell you that, you know, you can replace a lot of fields that have error in them once you cull through them for a day and actually, you know, take a chance at going through them individually. And as somebody who's done a lot of data engineering, I can tell you that, and I'm sure a bunch of people here can tell you the initial part of any project is really going, if you're doing it right, is going through those data sets and telling a client exactly how much error there is due to, you know, like you said, just stuff that's just been garbage in and garbage out, right? Because if the issue is that the data fields are useless, well, then you got to collect new data fields. But you can determine that a little bit with the machine learning side from the parts that don't have error. And so I think it's kind of that balance between the two. There's no perfect solution, I don't think, but there's some things you can do there that I think are really valuable on the unsupervised side, as somebody mentioned before, in one of the groups I was in, just making a map, making a kind of cluster of, you know, these ones are kind of over here, they're really clean, there's not as much error, and this is how much they're helping the value of the objective function. I think you kind of have to play kind of back and forth like that. Yeah.
Okay, thank you. Appreciate that.
I don't see any other open questions in the chat. Mr. Merkel, do you have any other questions?
You might be muted.
Yeah, sorry, I was.
It's a great presentation.
Yeah, one question for mid-sized companies, assuming you need a fairly large data set to do the training, is if they use a data set that is multi-company, does that mean every company ends up with the same result? You lose your ability to distinguish your performance?
So let me clarify. So you said, say there's multiple mid-sized companies, but they have the same data set, right?
Well, they're in the same industry. They have, you know, essentially the same data. Yeah.
So then my argument would be, I guess, whoever has been able to cultivate better features than another company has the advantage. Because if the same vendor comes in, or the same consultant comes in, or the same data scientists come in and they apply the same models, you should arguably get the same results, right? And that's kind of the beauty of data science to me, is that it really is data driven. Because if it wasn't like that, then it would all just be, you know, Fugazi. It wouldn't be very realistic, right? And so I think the argument there is that if you're a mid-sized company, you have room to collect certain fields that might be a little bit more advantageous than others, and that's what will give you a leg up, opposed to applying some better model, which is very ephemeral and fleeting. In the next month, somebody could apply a better model, right? So, but with the data set situation, as a company, you have control over your ability to kind of outcompete others in the machine learning side, where if you don't focus on the data sets, you have no control, in my opinion.
So what you're saying then is, how much does the use of AI diminish the power of corporate culture? Because I know, as a marketer in my background, you could have 5 companies in direct competition with the exact same research data, they'll interpret differently because of their cultures.
Yeah, and yeah, sorry, I'll let you go more. Sorry.
No, so if I'm hearing you correctly, using AI would tend to strip out that cultural factor that would make the difference in understanding.
Well, I guess what I would argue is that cultural factor should be represented in the data set. And if it's not, then
Okay.
there's probably something that you're missing, right? In the future. Of course, right now, like, look, I mean, people aren't killing it with AI yet. It's not everywhere. It's very hard to use. Some people somehow like spend a lot of money and on time to focus on it, and they sacrifice other parts of their business. But yeah, my argument would be that it would be, of a similar nature to kind of what I said earlier, which is that, your culture should be represented in your data. And that's kind of what I was getting at with the human side is, we're not letting the human intelligence that exists in companies, all these heuristics, all these things that we all know from learning over time, regardless of the theory that we're supposed to be doing, that just isn't represented in most data sets. And it's not because it's impossible. It's mostly because people just aren't thinking to do it. And I find that you can represent, like I said, with the moon phase situation, right? You can represent stuff that people are picking up on in data if you let it happen, if you instigate it. And I think that's kind of how you kind of outcompete or kind of get edge over companies of a similar nature doing a similar thing. Because I guarantee it's a different culture.
The culture, in effect, changes the data. Okay.
Exactly. And in fact, you should then be really interested in the culture, even just from ROI perspective, like we all are, some corporations pretend to be, because of the direct data set difference it'll create.
And we have another chat question. Kevin's asking if there's a large data set, how can we analyze it to make it more productive as well as improve the data collection generating going forward?
If there's a large data set.
How can we analyze it to make it more productive as well as improve the data collection generating going forward?
So just to expound on that, Lucas, I really resonated to me what you said about the quality of the data is very valuable. And so I know I've experienced a couple situations, and I know of a couple of colleagues that are struggling with, they have this mountain of data, but it was just data that was just generated. So it's just like piling up like dirty laundry in a teenager's closet. And so you have it, and the first thing you want to do is say, okay, we got to make our AI better, because I also agree with what you said about AI. So let's take this, and we want to be able to process it, to weed out the garbage that's in it, but help us focus, and then use that to maybe find different areas of data we have to gather, just so we can correct that bad history and move the future history with that data-centric approach, so we're generating high quality assets. That's
yeah, I think you put it really well in, kind of common sense terms, and just to put the non-common sense terms on it, I think it is as simple as seeing AI as a tool to better your data sets instead of the other way around. Like you can do, just even if you remove heavy duty AI, right? If you get just kind of the limited data analytics perspective, whatever that kind of means, but assuming that means like no serious AI, you just start making charts and graphs. I mean, use the human intelligence then. If you don't have like a person who can make a lot of good models, start using, Python, or have any engineer, any coder, anybody there can learn. I would say if you give them a week, how to go make a bunch of matplotlib graphs and these kinds of things, where you can start to visualize like, all right, we have a bunch of data, let's sample from it. So which any data engineer can do, and you sample from it and get a normal distribution from it. It's considered, or a Gaussian, and that allows you to avoid bias, because you don't just get the first 500 or the last 500 or something like that. And in that sample, and if you keep sampling over and over again, you should get a representation on a visual graph as to which ones are not doing much, or are just erratic and just have absolutely no coherent signal that they're giving you, right? And then if you throw in AI, obviously, then you can actually start looking at like which one of these are helping you reduce error, quite simply, or whatever the objective you're interested in. And I think you put it pretty much perfectly, right? And I think that's how you go from big giant data lake that has something interesting in it that we don't know, to just the interesting signal. And obviously you reduce costs, because storage is expensive on top of that. And a lot of people think you need all this giant data, but I've used deep learning models with 1,000 data samples, right? Everybody thinks you need 1 million or 10 terabytes. I've used it on small amounts of data. I mean, I've had many engineers under me. It wasn't some genius stroke that I was able to do. It's a common thing we do at my company. So it's very, very easy if you have the right people in place. And I think a lot of even young undergraduates and obviously graduate students, you don't have to pay them $400,000 to just go in there and start actually creating demos and prototypes of things that are tangible.
And so the key to that is you have to have objective statements that you're assessing that big pile of data against to put it into those plot maps.
Yeah, exactly.
Okay.
Because otherwise, what were you collecting it for in the first place, right? Yeah, you have to have some type of objective that could be represented in an objective function in machine learning algorithm, and almost any objective can in some way. Maybe it doesn't get it exactly like you want, but it gets a lot of it, you know, and so forth.
Okay, thanks.
Awesome.
Great. We do have a question from Newell. I don't know if Newell's muted or not. Newell's asking, how similar is the data set cleanup activity for an AI compared to that done during an ERP migration? Newell, you there?
I am.
Good.
Yeah, I just want to know, is that a reasonable analogy for the type of work that has to be done? I know when you do, and I think a number of folks here have done ERP migrations, you do have to go through quite a lot of data cleanup because a lot of companies are just not that particular about how they maintain all their data. Otherwise, a new ERP system isn't going to work well. And I just wondered, is that a reasonable analogy or not?
I mean, here's the thing. I think some people would say, no, that's not a reasonable analogy at all. And I would think those people are wrong, because I think kind of where you were getting at there is you learn heuristics while you're doing that are actually the same heuristics that you need to determine with an AI model if data is useful or not, right? Because the point is, with the new ERP, you have a more refined objective ideally than the old one had, and that's why there's so much kind of chaos in the old one. And I think that's basically a perfect analogy for the kind of transition you want to make with an AI situation, right? I mean, like I said, you don't have to have a machine learning model. It can be kind of data analytics that everybody can see. And even if you are doing machine learning, there should be, it's called EDA, exploratory data analysis. There should be graphs, there should be visual representations. And if there aren't, for, you know, stakeholders or supervisors or executives to see, then you're working with somebody who is either lazy or you know, they've been skating away on the fact that people don't know what's possible technically. And I think that's a good reason why people who, for example, have done things like ERP transitions start getting involved in the supervising of AI engineers. Because to put it frankly, like I said, most AI engineers are pretty young and pretty naive, especially about business objectives, and have almost no business experience, even if they have got a masterful PhD and everything. You know, I was in PhD groups, and when I first started in business, I was making a lot of big mistakes. So I think if you have somebody who's worked on ERP transitions, get them involved in supervising, you know, the data science intern who's trying to make some graphs to show certain things are valuable, right? Because they'll help them avoid stuff that's just cool and shiny object and actually go after the signal that you're really going for. So I think that's a really great experience to have, because it's just common sense, redundancy, and basic things that improve business that are actually missing. Those foundations are missing for most data scientists. So yeah, I think that would be great.
Lucas, does this, a lot of this keeps feeling like it's coming back to the model, you know, driving from the model versus the data. Is that something, because every answer that you're giving me, I kind of in the back of my mind, I'm thinking this is because people are driving from the model to the data and not the data to the model, because they don't know how to think in that direction.
Yeah, I think it's because they think of AI as just the model. It's kind of like, you know, a human brain or a mind is not the same as a brain, right? A mind is made up of the brain's interactions with culture, right? If you put a human in a box for their whole life, they're basically going to be a potato. So like the similar thing is with AI. I think everybody goes like, oh, the model, that's where the cool stuff is. That's where the hype is. But in reality, there's so much intelligence cooked into a data set. And obviously we started with rule-based systems where there was almost no intelligence outside of the human intelligence going on. I think we need to get some of that experience back, some of that kind of expert system style of kind of criteria back. And I completely agree with you is, you know, be it, you know, the lazy marketing that existed, or, you know, the hype, or, you know, whatever kind of typical thing happened, everybody started focusing on the models. And I think that's a problem because models are really complicated. Like they really shouldn't be interpreted by everybody. And I think data sets are not, because in fact, you know your data set before you ever even hire anybody to model anything, right? So people should come in ignorant to the things that you know about your data set to a certain degree. And if not, then you might have a problem because, you know, just typical kind of job two thing, people will just start to kind of drag their feet and they'll just do the stuff they did in their programs previously, right? And you don't want that. You want the things that you want. So yeah, I think thinking from the data set as the main asset is really the way to go.
Thank you.
So Lucas, on that note, would a model-centric approach be more like you've already found the conclusion, you're creating evidence to validate it?
Yes.
Versus where the data-centric approach leads you to, I call it the truth, and links up things that you didn't think you had, you know, that were there. Okay.
I think that's a great way to think about it. Yeah, 100%. I mean, they both have biases. They both have all these things in there that can trip you up. But I 100% agree with that.
This has been great. Thank you.
Awesome. Yeah, it was great to talk to everyone. I'm glad we could, you know, kind of keep it casual. It didn't have to be too presenty and stuff. It's always my preference. So I'm glad. Thanks.
Beacon is the premier executive networking organization serving the Mid-Atlantic region. To learn more, go to beaconforlife.org.